Hello, welcome everybody to our second Bathing Water Science seminar. I'm going to let the presenters introduce themselves, but we're going to have two sets of people, two independent scientists, and we're very lucky to have two senior figures from the Environment Agency. You will have a chance for Q&A at the end. The questions will go in through the chat. We do ask that you keep it on the big picture on the science, because none of our presenters here are specialists on the local area, can't answer sort of beach specific questions and so forth. And with that, I'll hand over first to Julie and then Catherine to introduce themselves, and then if Ian and Andy can do the same, and then we will kick off with Julie and Kathy's presentation. Thank you very much, everyone.
Well, hi, thank you very much for the invitation. You might wonder why you have someone from the US here on your webinar, but I've actually done my PhD at the University of Surrey, and the topic was looking at sources of pollution impacting our local bathing waters and devising solutions. And so I can give a bit of perspective on what we've done and how it worked here, and hopefully it will be useful, sort of the process that we went through.
Hi, I'm Kathy Pond. Thanks so much for the invitation. So I work at the University of Surrey in the School of Engineering, and I've spent most of my career in and out of bathing waters, literally and academically. So working also with the World Health Organization on their guidelines for safe recreational water.
I'll introduce myself. I'll go next. Hi, hello everybody. My name's Andy Rogers. I'm Water Quality Planning Manager for the Environment Agency at the national level, and the team that I lead, for which Ian's a part, lead on the implementation of policy around bathing waters. Ian and I have been involved in that for a good number of years, actually. We'll tell you later about how we do that and what our role is. I'll hand over to Ian.
Afternoon, everybody. Ian Dunhill, work for Andy Rogers in the agency, as you said. I'm senior advisor, leading on bathing waters. I've been doing bathing waters for most of my career in the Environment Agency, from sampling through to investigations, through both regional and national teams. National team now is the kind of the link between the politicians on one side and the practicalities of the people that actually have to do the doing on the other side. So my job kind of bridges those two.
Shall I start my slides, Simon?
Please do. Thank you very much, Kathy.
Okay, I'll share the screen. Okay, so again, thanks so much for the invitation. As I said, I am working at the University of Surrey. Just trying to move my screens on. And I've been working sort of on bathing waters on and off for around 20 years. From an academic perspective, my leads are World Health Organization Collaborating Centre for Protection of Water Quality and Human Health at the University of Surrey. And I've been working with WHO on a number of publications over those years on bathing waters. So I'm just trying to move my slides on. So we've already introduced ourselves, so I'll skip this slide and Julie can add any details as she wants to. So just getting into the sort of the couple of key messages that I would like to get across. I think it's very well recognised that there are many factors that determine the quality of bathing waters. And these can include sources that originate from the natural environment, as well as those that are in the direct control of the utility asset management. But also it's very important to realise that environmental conditions can serve as mechanisms of delivery. So natural impacts on water quality, they can include presence of shorebirds, of dogs. Further up the catchment, fecal runoff could come from cattle, from horses, pigs, sheep, etc., as well as potential influx of nutrients that are associated with agriculture. But then there's also lots of other sources of pollution, and particularly where we're looking at monitoring for fecal indicator bacteria. Other important factors include the presence of algae, of litter, misconnections, population growth, change in building occupancy, behaviour of coastal users, and they all have the potential to contribute pollution to our bathing waters. And then we shouldn't also forget about climatic and environmental factors. So enhanced precipitation, for example, can result in a greater delivery of the potential pollution sources, and that may become much more significant with climate change and warmer seas in the future. So before moving on, Julie will pick up some of these factors in a bit more detail in her presentation in a moment, but I just wanted to say a few words about the WHO guidelines for safe recreational water quality. So these were updated in 2021. The focus of those guidelines is protection of public health, and they recognise the benefits of recreational use of water as well as the potential adverse effects. So I think that's where the sort of the real public interest comes in, is that so many people are using bathing waters now, and really recognise, you know, the health benefits of using blue space, if you like, for swimming or for recreation, as well as those potential adverse effects. So the guidelines set out recommendations for setting national health-based targets and conducting surveillance and risk assessments, and puts in place systems to monitor and control risks to the bathing waters or recreational areas. I think it's also important to speak about the fact that microbiological sampling has got inherent flaws. I think, you know, anybody that's involved in this sphere knows that. They know that, you know, sampling the water is good as an indicator of water quality, but it only ever provides a snapshot of that point in time. And of course, by the time the samples have been incubated and gone to the lab and the results have come back, the results are retrospective. So the emphasis needs to be really on preventative risk management through site-specific recreational water safety plans, if you like, and development of management actions that will reduce risk factors for pathogens. So we need to move away from being reactive to being proactive. So just a couple of words on what we're doing at the University of Surrey in the next 3 years. We're trying to undertake a 3-year project which will be aimed at investigating sources of bathing water quality pollution in various locations on the south coast of England. And the emphasis really is on looking at the sources, because I think everybody wants the same goal, was working towards the same goal, and we can't implement effective management solutions if we don't know where the pollution is coming from. So the project will follow a systems approach, and I try to identify relevant pollution sources and environmental data for specific locations using both current and historical data, and then try and identify how much each source contributes to the overall pollution at each location, and then assess how sources interact with each other and how they influence each other. So why is it important? As I mentioned, sort of the key message I think really is here that there are multiple sources of pollution, and there's been all sorts of studies over the years, academic studies, which are showing how fecal indicator bacteria are influenced by environmental factors. You know, algal mats, for example, research shows that they can act as reservoirs for bacteria and pathogens, and that will then affect the water quality. A new report out by the New Zealand Ministry of Health showing concentrations of fecal indicator bacteria is higher in sediment than the overlying water. So, you know, where then sediment, sand, fine sand is disturbed, resuspension can cause fecal indicator bacteria and pathogenic microorganisms to increase in the water, or the concentrations to increase in the water. Lots of information on land-based practices, changes in agriculture, for example, can increase nutrient runoff, and that can then promote algal growth, and that will again impact on bacterial populations. And Julie will, I think, tell you a little bit about beach characteristics with the work that she's done, where it's been shown that you have better water quality at open beaches. So, you know, the coastal configuration can have a kind of a huge impact on the bathing water quality. Also, where you've got low human and animal presence and bird management policies in place can all help to reduce the indicators or the fecal matter in the water. And of course, stormwater management and controlled beach access is also important. And I missed off at the beginning, but I think it is quite important to note that a number of studies have shown that there is often no correlation between overflow events and poor water quality. So that really suggests the need that we need to explore the other sources. And that's not to say that there is no correlation ever. There is, and I think, you know, water companies are, you know, first to admit that that does happen. But I think it's really important to understand that there are so many other factors that are that need to be taken into account when we're looking at why our bathing waters can be of poor quality. And my final message really is, I think that cooperation is really key to success. As I said, everybody who is involved in this this subject wants the same outcome. We all want to improve our bathing water quality. And we know that there are multiple parameters coming from multiple sources. So cooperation between, you know, the huge number of stakeholders that are involved in the topic, agencies, water companies, you know, local communities, huge number of citizen science groups, for example, local authorities, as well as academics. It's really vital, you know, to identify the sources so that effective management options can be put in place. I think it's also really important that we have independent analysis of the multiple studies and findings of those studies. And finally, context-specific solutions are needed because every beach is different, every bathing water is different, every site has got different sources coming into it, has got different configurations. It's a really dynamic environment, and, you know, impacts of climate change, for example, affecting environmental factors will impact on those bathing waters in different ways. So cooperation is really key to success. I'm going to pass now over to my colleague Julie, and she'll give you some examples from a case study that she was managing over in the US.
Hi, I said thank you again for inviting me. I went to Surrey and I did my PhD on looking for sources of pollution impacting our local beaches. And I had a unique position because I was the director of a local public health laboratory, a certified laboratory. And we had very few tools available to us, but yet we knew that we had failing bathing waters and that a portion of our local economy and of course the enjoyment and opportunity of our citizens depended on having these some odd 4 or 5 local bathing waters open. So as I went through and looked for opportunities to do my PhD, I thought, well, this certainly can't be just a problem in the US in the Great Lakes. So where I lived was just about an hour north of Chicago on Lake Michigan, that it must be a global issue. And I started looking at resources and opportunities for sort of a combined multidisciplinary PhD. And that's how I chose Surrey, because I wanted that engineering, microbiological, coastal management perspective. And so I was able to then look at sources that would impact these local resources. So this picture is actually one of when we did an initial survey. I could tell you that using a pail is not effective at capturing and of stormwater that's going to impact your bathing beach. But we'll go on to the next slide. Please, Kathy.
Yeah, I'm moving them on.
All right, thanks. And then, as Kathy said, go back, there's a lot of potential pollution sources that could impact. So we had sort of the same things that you're seeing there. We had stormwater infrastructure. We had wastewater infrastructure. And of course, those are the things that people think are the smoking gun. Oh, there's been a release of stormwater or a release of sewage, but there's many other things. It depends on the, as Kathy said, on the site. So impervious surface runoff from the pavements around the beach itself and up into the catchment, that because there was a tributary. So there's so many things that we think that could potentially impact the bathing waters. And then if we can think about, what sort of assessment methods do we have? So when I started out in our laboratory, we could do agar-based methods for E. coli or enterococci, and of course, measure rainfall and sort of rudimentary things. And when I started out, that's all there was. But as time has evolved, there's many more methods available that we can use to help survey the site and get a better idea of exactly what's impacting water quality beyond the traditional fecal indicators. If there's tributaries, there's different types of things we can look for, nutrients that could help with enhance algal growth. The Great Lakes, we only have a small tide, we have a true tide, but I mean, these are things that are applicable across the US, and I've worked with local, state, and federal agencies, as well as my counterparts in other US states, trying to adapt these methods and suite of methods to be site specific, as Kathy said. We could go maybe to the next. And as she said, it's really important to choose the right methods at the right place in the right time. So there might be many commonalities, but not all the sites are equal. And you need to choose the right tools. And I think as we went along and there were more molecular methods, there's something called qPCR, where we can do water quality assessments for fecal indicator organisms in real time or near real time, a few hours, or things that will help look for DNA-based tests that could then trace it back to a specific thing, cattle, dogs, seagulls. Everybody wants to do the thing they see on the telly, right? They want to go and say, I'm going to do the DNA test. And they're quite expensive and they're not always accessible and easy to do. So it's not that you should abandon the other ones. I mean, your powers of observation, your ability to look at the data from the fecal indicator organism assessments are really important, I think, as a first step. And then to add these other things in where they're necessary and will actually yield some useful data over and above what you already have, not just jump into the most technical analytical method or something that you've seen. So next. So one of the things that I did when I was doing my PhD was to look at resources, then how to take observational data. So one thing is important if you're looking from site to site and things that are under your own control, or you're trying to work with other people to look at their data and see if there's commonalities, and you can come up with solutions that might be broadly applicable, is to be able to collect the data in the same way. And the WHO had a framework for data collection, and we were able to adapt it locally to come up with something called the Beach Sanitary Survey, which is guided data collection for these site inspections. And we can do them either routine, which we call routine in the US, or on a sort of an annual basis, which I'll show in a future slide. So when we go out to pull a sample, we were trying to take data that would be useful when we looked at it retrospectively or concurrently to having any water quality failures. What sort of things would act as drivers for loading fecal indicator organisms to the nearshore water? And this is the suite of things that we came up with that would be useful. And ultimately, it's proved to be a good method in the US EPA, sort of the counterpart to the EA, then developed formalized tools both for the Great Lakes, for the freshwater portions of the US, as well as for the coastal areas for our marine waters. And so the ones that you see highlighted on this slide, I'll just have a bit of a quick examples of how we use that data and the information it yielded. Go to the, so Kathy had mentioned algal mats. So the algae in the water can, in fact, act as a reservoir, as she said, for fecal indicator organisms, made even more so if you're having delivery of nutrients like phosphorus and nitrogen. If the water's warm, there's not in a good circulation. So if you have an embayed area where those mats can kind of senesce and sit there, we've seen that the concentration of bacteria in this example, E. coli, is one higher in the mats themselves than in the surrounding water, but it also increases with the amount of algae present. So that was, important to know. So is it in a protected area? Maybe you can't remove it because you're in a protected area where that's dependent on some sort of wildlife. But if you're in an urban area like we were, there was no restriction on removing these stranded algal mats or mats in the water. And so that became something important to do because we knew that they were acting as a reservoir and then releasing the fecal indicator organisms into the surrounding water under the right conditions. Next, please. The other thing that stood out was the shorebirds. And so in this slide, we could see if there was no evidence of seagulls within 1/3 of a meter of our sampling location, the fecal indicator organism concentrations were much less versus if there were seagulls present. So that's and then also the other function, Kathy was talking about the configuration and the size of the beach. This is an example of a beach that was narrow on the one end and wider on the other. And we could see that the bathing water failures and the number of gulls increased with increasing beach width. And so this is illustrative of not only are the shorebirds a source, but then, the physical attributes of the beach kind of influence their behavior. So they were loafing, hanging out, at this wider portion of the beach. And so maybe that would lead us to some sort of action to take, could we naturalize portions of the beach or put some sort of deterrent measures that would make a difference. So if we go to the next slide, we can then we did some gull interventions. And so before the intervention, the fecal indicator organism levels were higher than post-intervention. And we then followed up with specific markers. So was that due to the gulls being there or was it due to something else? And so we looked at a marker that was specific for gulls, and we looked at no intervention and post-intervention, and you can see both the fecal indicator organism levels and the marker associated particularly with the shorebirds decreased as a result of those actions. Here's another example of using data for fecal indicator organisms, visual inspections, and then adding in the microbial source tracking and the community profiling, which are more complex methods. And so in our community, there was a river that discharged just to the south of the beach. And so we could see at some point, so this picture in the middle is where we had a stormwater outfall, and we could see the presence of this foaming. So we know there's some sort of illicit connection somewhere within the system, but we wanted to know, is it impacting the shore, the coastal bathing waters? So we did a study using the fecal indicator organisms, and we went before it rained, we went after it rained, and then on the left, like the red squares and the little red flag, we could see that there were areas where the fecal indicator organism concentration increased significantly post-rainfall versus the yellow or green ones where there was just moderate to no change. And then, so we know that the tributary had the potential to impact. More likely it was direct stormwater discharge onto the beach. So there was a large stormwater outfall And we subsequently did some mitigation where the stormwater outfall was redirected to a constructed wetland. So it captures and retains and infiltrates that stormwater prior to it discharging to the immediate bathing waters. And of course, we've gone through and done significant retrofit of any sort of failing infrastructure. In this case, it was a misconnection done by a builder where they were discharging the sanitary waste into the stormwater system versus where it should have gone. But then looking years on, we wanted to know how effective these retrofits were. And so we used community profiling, which is a tool that was then available to us. And if you look, it's color coded. So this IEB overflow was the stormwater infiltration, evaporation, basin overflow. The yellow and the purple are locations on the river itself. And then the N1, N2, N3 and the harbor wall are areas in the nearshore water. And we can see that the colors are clustered together. And so there's some similarity within the river samples. There's similarity within the nearshore waters, but positively, the water, the bacterial communities are dissimilar that are in that infiltration evaporation basin. So it means that we're being effective at isolating those from the nearshore water area, which is important. So we're retaining that dirty stormwater, allowing it to infiltrate rather than discharge. If it was mixing, they would be more closely clustered together. So the blue dots would be by the red, green, and orange dots. Next, please. So as I said, there was two types of sanitary surveys. There's this routine one where we collect all the data that I showed on the previous slide at the time of whenever we collect a sample. And then once we look at something, cast a wider net. So we look at all these sort of things to see if anything's changed, because local areas they're dynamic, they're not static. So sources that we might have found one year, we might remove, but maybe there's a new source. So it's good to keep at it. And so these are some of the things that we would look at an annual basis to see if anything's changed. Next.
Yeah.
And I wasn't the only one. I said, so it's not unique. It's not unique to the UK or to the US or even within, in the US. So it feels like it. I think when we were in our local community, it felt like, oh my God, this is so bad. And why is this happening to us? And nobody's helping us. And it turned out there's lots of people that felt the same way. So 25 years ago, we formed something called the Great Lakes Beach Association, which is a binational cooperative group between Great Lakes beach managers, local, state, and national agency representatives, local officials in the US and Canada to try to pursue this healthy bathing water that we all want and share information on our investigative modeling methods and information system, how we get that information out to the public. So one recent example is the International Joint Commission, which is the governing body that regulates Great Lakes water quality between the US and Canada. We worked with the Great Lakes Beach Association. We work with them to look at how people are utilizing this US sanitary survey and equivalent Canadian site inspection tools to help understand environmental and human health risks affecting Great Lakes water quality. So if we go to the next, I think I'm running out of time here. So maybe they can share the link. So there's a paper that's out that people can access, and it talks about how many people use the tool and what sorts of sources they found as a result of using it. And then the last point, I think, is that there is opportunities for citizen science to contribute. So 41% of people, when we did a survey, felt that relevant data could be generated from partnerships with beach users and citizen scientists, though it's underutilized at present. And some of the things that I think they could share is getting the word out to the public if there's important messaging, or perhaps collecting data and observations that would trigger investigation by whoever the regulatory body is, whoever's collecting those samples, and then helping to inform remediation activities of course, the local people are there all the time, and they can observe something that might be informative to authorities that are regulating these bodies of water. And so a good example, another link that could be shared is Swim, Drink, Fish Canada. They have a really active community-based water monitoring program, and they have rigorous training that has quality assurance and quality control protocols to try to ensure that the people that are collecting the data are doing it in such a way that it's actually useful. You know, if everybody's collecting their data in a different way, not only the scientists that are responsible, but also the citizens, it becomes less useful because you can't compare the data. You can't compare, in our case, between US states or between other municipalities, or you can't compare the data that's collected by the volunteers to your data because it's too dissimilar. So it's important to have some sort of rigorous sort of protocols in place so that they're generating good data. Even if it's not the same exact type of data, it should be some sort of additive data that's proves useful. Kathy, to wrap up, I think.
I think that was your slide, though. You know, it's just kind of, I guess, just to re-emphasize, you know, that we're starting this project in Surrey. We've actually done a year, and hopefully by looking at existing data, historical data, and potentially new data where we think it's needed, we'll be working with citizen scientists as well, looking at, you know, all the different potential sources of pollution in specific locations. We hope we'll be able to come up with a model that could be used to allow effective management options to be considered and then potentially implemented.
Thank you very much indeed for that. I'm particularly keen on that international perspective. What a great project over there on the lakes. I'd like to now hand over to Andy Rogers and Ian Dunhill. Thank you very much.
Yeah, thanks, Simon. I'm going to expose my inability to master Teams, but I'm going to try and present. I'm not used to presenting in a webinar mode, but see if that works. Are you seeing a slide?
Not yet.
No.
Not yet.
That's interesting. Why is that? Ian, don't know if you can help me out.
You should both be set as presenters, so
And you can try share and then share a window. And if you do it in presenter mode, that should give you what you need, I think. That's your desktop, Andy.
Not doing very well anymore. Now I've got this.
Stop sharing, and then if you want to send slides through.
I'll stop sharing and see. Now I'll share. You know what it's like when somebody's leaning over your shoulder. And bear with me. How about that?
Okay.
Yeah. Yes, you see a slide?
Yeah.
Aha, marvellous. Okay. Sorry about that, but pause for thought there a little bit. So I'm going to give you a quick overview as to well, bathing waters, I suppose, and what they are in the context of the role that the Environment Agency has in managing aspects of bathing waters. And then we'll go on to talk about some of the detail of how we do that. I think my reflection on what we've just seen from Kathy is the issues that we're facing in the UK, in England, are very similar across across the pond. So in some ways that's very reassuring, and I think there's a lot we can learn from each other on how we manage some of these things. Okay, now struggling to move my slide on. Has that changed?
Yes.
Yep.
It has. Marvellous. So I suppose we thought we'd start with what are bathing waters, and this is framed in the context of the law in England and Wales actually, which sets out what a bathing water is, and those are designated in English and English law. So a bathing water is defined, as I'm aware, a large number of bathers is expected, and a decision currently is taken by the Secretary of State, delegated to Minister, on whether waters qualify for being designated as bathing waters, effectively on the number of bathers that are present. And if a designation is taken for by government, it's then monitored during the current bathing season. Currently, as the bathing season is between May and September. Bathing waters can be all types of waters, coastal lakes or rivers. We've seen an upsurge in interest in recent years in the latter. Traditionally, coastal waters were where most bathing waters, as the picture there shows. We as an Environment Agency monitor and sample those bathing waters, and we use, one of the roles we've got, which I'll come back to in a little while, is that we produce a classification then for those bathing waters on an annual basis, but using the four-year rolling data set up to that point to give an overall view of water quality across a long period of time. I think as we saw earlier, it's quite clear that water quality does vary very frequently and in response to local sources and local characteristics of the beach. Having a bathing water designated then requires it to be protected from pollution, and we have a role there as an Environment Agency in exercising our regulatory powers to make that happen. Right. Has that moved on? It has. Marvellous. So there, I suppose going back in time, the legislation that we're operating under at the moment is the bathing water regulations. They derive from European legislation, and the standards that we're seeking to achieve there to try and ensure that bathers' health is protected, as Kathy alluded to earlier, derive from the WHO work and guidelines for safe recreational use of waters. So those are carried through into UK legislation, the bathing water regulations. Those regulations have just yesterday actually received some modification, which will come into force, modernising a few aspects of the existing regs. They'll come into force over the next few months up to the start of the next bathing water season in May. But though the standards that we classify against are derived from those health protective standards and advice from the WHO. In terms of responsibilities, I think I've alluded to some of this already. DEFRA, on behalf of government, undertake the role of designating bathing waters and in general enforcing those regulations that I mentioned. They're also responsible for implementing reform, which is happening as a result of changes made yesterday. Ourselves in the Environment Agency, we've got quite a specific role as a regulator overall. That's our primary purpose for being. We were charged with monitoring those bathing waters and classifying them, and we publish classification results on an annual basis. This year at the end of November. We're also charged then with exercising our regulatory powers to reduce pollution sources, so that the standards set by the regulations can be achieved. We also provide a charge with providing information. We do this through our Swimfo website, information on each bathing water, the likely sources of pollution, and so on, and also a history of the results and current classifications of each site. We also publish information there on pollution incidents when they occur, and as Ian will talk about shortly, we provide some predictive warnings through that site. Local authorities have a role under the regulations. It's local authorities who ultimately hold public health responsibilities. We as an agency don't, and they provide signage at each bathing water and in response to incidents that we provide that information to them. Under the regulations, under the law, water companies have a specific role of informing both local authority and ourselves if there are pollution incidents affecting bathing waters. More widely, of course, and not under the regulations, the water companies are required to achieve the permits that they operate against their assets to reduce pollution. I think I'm coming on to that now. Yeah, so of course, in the context of water companies, and as Kathy's pointed out earlier, there's a vast range of sources of contamination of bathing waters potentially, but in the context of sewage, which is largely the domain of the water industry, water companies, the Environment Agency sets permits for discharge of sewage such that the standards within the regulations can be met, and typically for continuous discharges from sewage treatment or wastewater treatment works, they're either relocated distant from bathing waters, or they're treated in a way to bring down fecal indicator contamination through disinfection. And storm overflows, which storm water overflows, which are very topical, are designed. The design of the permits for those is intended to reduce spill frequency, so that bathers do not come into contact with raw sewage is the intent. Right, so I think this is my final slide before I hand over to Ian. Pictures there show the scale of infrastructure needed sometimes to reduce stormwater and wastewater contamination. And in recently, I'm not sure exactly the time scale, but I think over the last 10 to 15 to 20 years, we've seen something like £2.5 billion worth of investment by water industry to meet the permits that the Environment Agency sets to protect those bathing waters. So, and it's an ongoing challenge. There's more to spend. There's more permits to refine to try and tackle that aspect of bathing water contamination. And of course, that's not the whole story. But I shall now pass over to Ian. And Ian, just give me a nod when you want the slides moving on.
Yeah, if you can stop sharing, and then I'll go. Fine.
Oh, okay.
Oh yeah, it's fine. Yeah, you can drive. So fecal indicator organisms are what we use to measure. These are the things that are set in the directive and the regulations that we follow. Fecal indicator organisms in themselves are bacterial indicators, and these bacterial indicators are used because they've got a long history of being used. They've been used since the sort of turn of the last century. They're quite easy to measure. And when you have sewage, you will have an awful lot of these bacteria that you measure. You can see in the pictures, we've got some plates on the bottom. And basically what you do, you take some water, filter it through a membrane, put it on some agar, and grow spots, and then you count the number of spots, and that's how you get to the results that you're looking for. There's two types of bacteria that are used to make these assessments. There's Escherichia coli and intestinal enterococci. Both are assessed independently, and they can give you an indication of the degree of contamination with fecal material that's in the water. They're very useful. They're very easy to measure. They are really good at measuring sewage. If you have sewage contamination in the water, you will also have a lot of these indicator organisms, but they're not specific to sewage. So you can also find these fecal indicator organisms in other sources of fecal material. As was mentioned earlier, you can have it in birds, you can have it in street runoff, you can have it in agricultural runoff, you can have it growing in the beach sand in itself. And so there are useful indicators, but they're not the be all and end all. But they do give you an indication linked to epidemiological studies that when you find high numbers of these, you can also notice an increased rate of illness in the bathers. And the epidemiological studies are really important because that tells you about how to set your classification standards. Next slide, please, Andy. So I'm talking a little bit about how we actually measure them, how we analyze them. It's set out in law. So the methods that we use, they are prescribed in the regulations. So we've got to use those. We're not actually aware of current methods that can give real-time results that everybody, including us, would very much like, that are linked to directly linked through the epidemiological studies to the health outcomes in the bathers. So we sample and we try and make those sample results available as soon as we can. But it's important to recognise that there is a time lag between taking samples and before they're available. So E. coli takes, once it's arrived at the lab, it takes a day, 24 hours to analyse. Intestinal enterococci, they take 3 days to analyse. So if you go through the sort of procedures that we have, we take a sample on a given day, it gets couriered to the lab, results start to be analysed the next day, and it takes up to 5 days before all of the results are available. And on day 6, those results are on Swinvo, sometimes even sooner than that. So as soon as we've got the results that we use to measure the quality of the water, we make them available to people. The problem with that is people assume that that is relevant by the time that they get them. And what we know from the studies that we've done of bathing water quality is it varies really greatly hour by hour. So you can have typically 100-fold difference between a sample taken at one point in the day and a sample taken at another point in the day. So because of the fact that these samples have to be incubated and they have to be grown, and even if you had an instantaneous result that could tell you as you measured it, by the time these results are there, they're not going to tell you what the quality of the water is going to be that you're going to be bathing in. And they're not really that relevant to quality, particularly when you're talking about samples that have been taken several days ago, and the quality will have changed since you took those. So even if there was a new method that comes up that you could dip your probe into the water and it would tell you exactly how many indicator organisms are there, and these were the same ones that were linked to the epidemiological studies, it's not going to tell you what the water is going to be like in an hour or two or a couple of hours when you might be bathing in it. So it's why when we use the classification results, they're done on long-term trends, because that can tell you something, and that's important. Have the next slide, please. So the standards that we use to measure bathing water quality are set out in the regulations. There's different set of standards for coastal waters, transitional waters, and for inland waters. And these are measured by a statistical analysis, which means you take all of the samples that you have, and then you look at the range of quality that those samples are going to have. and it assesses using the statistical method called percentile. The percentile just simply telling you that it's almost like ranking the samples from worst to best. These statistical sites,
and I think where Ian left off there was explaining that this is how these are the standards and the statistical approach that we're required to use in the regulations to classify the waters on an annual basis. And that gives us certain information. It's particularly good at giving a long-term perspective of quality, which we can then use to drive the necessary pollution reduction, be that in agriculture, be that in water industry, be that in whatever source of contamination that we're looking at for particular water. What it isn't particularly good at is, as Ian indicated, giving a view as to what the quality is going to be like tomorrow or in a day or two's time, because of all the variables that impact on quality. Rainfall is a very big influence in coastal waters and estuaries. Tidal state and in particular has a huge bearing on quality. Beaches are affected by wind direction, and probably some of the seasonal effects and effects of sunlight are important. Sunlight kills off bacteria and pathogens, and you tend therefore to get a better quality during the summer months when natural disinfection is at its highest. So I think this slide was just to reinforce the range of. You're back in. I've just moved on to this slide and showing this going to reinforce the multiple sources of contamination, and actually mirrors very, very closely some of the slides we saw from Kathy earlier. But Ian, shall I pass back to you?
Thank you, Andy. Apologies everyone, that wasn't the best time for my internet to drop out, but these things happen. So the only other thing I was going to add to the previous slide was to say that when we're trying to use all the factors that we analyse and we find relate to bathing water quality, point a bit that being that when you get the conditions that reoccur that you've had that have been associated with the high results, if that happen again, chances are your risk of those higher results coming back are greater. So that's when we issue pollution risk warnings. But yes, it's great to see kind of when speakers agree on this type of presentation. Absolutely unplanned, but good nonetheless, to talk about the sources of pollution that one has that could potentially affect bathing water. So they're all coming from somewhere, and they're getting to the bathing water via a route. Sources that we know that are important at certain bathing waters. Sewage is probably the one that gets the most attention, but agriculture in a lot of bathing waters is just as important, and can indeed be more important in some places. Mentioning animals and birds, that can be a very important local contribution to the bacterial indicators that are in the bathing water. And it's even good to see that wrong connections are mentioned, because we do find those wrong connections. If you look in detail at surface water networks, you will find that a proportion of people will get their plumbing wrong and connect it up to the wrong thing. And what they don't realise is that then quite often means that they're effectively discharging their hand basin or their toilet straight into the sea, and that has an effect. So that's the sources. It goes through rivers, streams, through drainage networks, where it's dispersion, dilution have effect, and then it ends up in the bathing water. And there's also some direct sources to the bathing water. Unpleasant as it may seem, each of us carries a lot of fecal indicator bacteria in our bodies and on our bodies. So actual bathers can cause indications coming from there. There's also the sources that were mentioned about recycling and growth, where beach sediments, seaweed piles can grow these bacteria that we measure for it. And there's some natural sources in the soil. And so this is a really complicated picture. And what we're charged with doing as being the Environment Agency is to try and look at that. Next slide just shows some of the things that we try and do to address these. So the sewerage point sources, for us, actually, they're the easiest to control because they come from one place. We know what they come, we know where they are, and we can look at them. We'll set the permit limits, Andy mentioned earlier. So the conditions will be to second the permits in a way that they are meant to protect the bathing waters. And then we'll check, we'll act as a regulator and make sure those are being adhered to, taking the regulatory action if the permits aren't being met conditions. Then we move to the sort of agricultural diffuse pollution sources. It's much more difficult to control because it comes from a lot of smaller sources from a much bigger area. So it's boots on the ground to try and actually understand these things. There are some general rules that farmers are required to meet to keep basic standards, to keep the fecal material out of the watercourses. Picture here of some cows that have got free access to the watercourse. First thing a cow does when it goes into the watercourse is to defecate, and that fencing is a really well-known factor to keep the agricultural animals out of the watercourse to do. And we rely on inspections of farms. We give advice. We show them access to grants that they can use to try and control the sources through agricultural sources. And then urban diffuse pollution can be very problematic. So one of the very significant issues that we have is people misconnecting drains into their own properties. Picture on the top left is from a Connect Right campaign that was run a few years ago, trying to encourage people to understand what not to plumb into. So it's important that you try and control these sources that are coming in so that you're not putting foul water or grey water into the surface water system. You might as well be connecting it straight onto the beach if you're doing it. And then finally, the role of the local authorities can have to try and manage populations of gulls, moving them on, scaring measures, trying to put litter bins so they don't have access to them, even controlling them in that sort of way. And these are all important factors that we can use to try and improve bathing water quality. And each and every one of them has been important at some bathing waters across the country that we're trying to control. So that's it. Thank you.